So we started with a 0 for 84, counted all the way up to be a 10 for 1994. And then we plug that information into the calculator. The calculator will then take the data and do a whole bunch of things with it. We wanted to graph it to get a scatter plot. That scatter plot should have been a positive correlation for A. Letter B, the correlation coefficient was 0.99. So if you looked at your graph and the correlation coefficient was 0.99, what does that mean? Jacob?
It's almost a
Yeah, it was almost a perfect line. So 0.99, this number is supposed to be 1 for it to be exactly linear, but 0.99 is really, really close. So maybe one of the points were just slightly off, but otherwise it was almost a perfectly straight line. And then the equation, Emily, what equation did you come up with for letter C?
Y equals 2.
Good. So if you didn't get that equation, you probably entered a number in incorrectly. One number will change the answers. If you can't get the equation to come up at all in the calculator, please let me know. If you can't get the graph to come up in the calculator, let me know. You might be missing a piece or accidentally deleted something. But if you're having calculator issues, let me know before you leave today so that I can correct them now instead of the quiz on Friday. So the other questions that are listed below are based off of using this equation. So letter D says, what is the y-intercept? Well, we know y-intercept is the b value. So that would be 11.82. But I really need you to get in the habit of writing it as an ordered pair. So 0, because the 0 represents something, and the 11.82 also represents something. But a y-intercept is a point on the graph where x is 0. So what does the y-intercept mean in this situation? So you have to think, what does the 0 represent? What does the 11.82 represent? Try and come up with a sentence. How about a sentence for letter E about the y-intercept? Eris?
0 years, the percentage of households owning a computer should be 11.8%.
Okay, so she said at 0 years, the percentage of households owning a computer is 11.82%. I didn't include the at 0 years. What year is actually the 0?
1983.
Yeah, 1984. So in 1984, instead of saying 0, take the 0 and translate it back into the year that that represents. So in 1984, the percentage of households owning a computer is 11.82. Now here's the thing. If you look at 1984, the number up here is 13. Why don't those pieces match up? So this equation here, what does this equation represent? So what's that equation? Yeah, Dal.
The average.
It's the average of the points. And even though it's almost a perfectly straight line and all of those points almost fit to the line, they're still off a little bit. So this here, the 11.82, is the average line, or the line that goes through most of those points. But it isn't going to be exactly matching up, because this is 1 point on the graph, but we had to correlate all the points on the graph. So it's all right that 1984 has a 13, but yet in my sentence I have in 1984 the percentage is 11.82. So that sentence is based off of the equation that we calculated to fit as many data points as we could. Questions with that? Sean, how about the slope? What's the slope of a line? Our line. 2.5. How about 2.53? Do you know what this slope means in this problem?
On average, each year goes up by 2.52%.
Perfect. Yeah. So he said on average, each year, the number of households owning a computer increases by 2.53%. But this number is going up every single year. So somehow you have to say that every year the percentage of households owning a computer increases by 2.53. So whatever you want to say there, what Sean said was perfect. Any questions with that one? So make sure you have each year for every year and something about it increasing by that percentage. So I'm going to stop there because H and I, Abby has. So we'll let her talk about finding the x-intercept and what it means.
Okay, so I just took the equation and I plugged 0 in for y to find the x-intercept, and I got negative 4.67, and then you would get, that would mean it's 0%, it's year negative 4.67, which would be 1979.
Good. Keep it up there for a minute.
Okay.
You're good. So x-intercept means y is equal to 0. You have to get the x by itself and you get negative 4.67. It doesn't mean that your year is negative, but it means you're moving backwards in time. So you're going backwards more than 4 years. So if you go backwards 4 years, we'd be at 1980. But if we go backwards more than that, a little bit more, 2/3 of a year more, it should be in 1979. So in 1979, 0% of households owned a computer, which probably is pretty accurate. The only people that had computers were probably businesses, corporations, and a computer was not a computer what you think of a computer. A computer was the whole room. So the whole room was one big system, not really called a computer. They called it like a mainframe or Unix or something like that. But literally this whole room would be made up of computers. Has anybody seen Hidden Numbers? So in Hidden Numbers, they had that huge room with the one giant room of computers, and the computers, all they did was calculate data, like nothing else but calculate data. But it was one huge room filled with a bunch of computers, and there was like a couple of girls who were in charge of them. Hidden Numbers is a really good movie. You found it like a good movie, not just crazy math, science, right? It was a really good movie. Hidden Figures, is it Hidden Figures, not Hidden Numbers? Hidden Figures, sorry. Anybody else see Hidden Figures then? I got the wrong word. Yes. Yeah. Very good movie about NASA.
There you go.
It's good. All right, so 1979, make sure you got that year. You understand where that year comes from. It's because we're going backwards in time a little more than 4 years. Any questions with H or I? Nice job, Abby. The last two questions there say, according to the model, oops, wrong way. What would the U.S. household owning a computer be in 1998? So, David, what number did you plug in for 1998?
14
14 in for X or Y?
in for X.
And you got what for Y?
47.24%.
Yeah, so about half of the American households owned a computer way back in 1998 when most of you were, what, 7, 8 years old? No, you weren't born in 98. You weren't even thought of in 98. That would have been 2008, 7 or 8 years old. So you weren't even a thought in your parents' mind. The last question, I graduated in 1998. In the year, what year would the percentage of U.S. households be in 43%? So who came up with a year for 43%? Danielle, do you have a year? Or did you get a number? So the last question at the bottom.
1996.
Yeah. So we're talking about 12 years. So you plug in a 43 for Y. You solve for X. You get 12.32, which is 1996. Any questions on the front? So the back problem was very similar, but it talked about a tree being planted. And we have huge trees planted in our yard because I know they were planted a long time ago. So this one here, this family planted a tree in 1991 and they kind of watched it grow. So the equation you should have come up with was 14.75x. That means every year the tree's growing almost 15 inches. And then the y-intercept was 40.22. So your slope would be every year the tree grows 14.75 inches. The y-intercept, this one doesn't make sense. But in 1991, well, it kind of makes sense, but in 1991 it says the tree was 40.22 inches. Again, the actual tree was 47, but that's where the line is for your y-intercept. So we're going to let Eris do the last two problems for J and K, where we would want to know if it was 2015, what the height of the tree would be, or when is the tree 250 inches. So Eris has this one. She looks full of excitement. Come up here.
So much excitement. Yeah, that's good enough. For J, it's the equation 14.75 times 24, which how many years? So 2015 minus 1991, 24, you get 394.22. That's how tall it will be in 2005. And then K is, you write the equation, you needed 205 inches, subtract 40.22. You divide and it is 14.22. You add 1991 plus 14, 2005. So in 2005 it will be 250 inches.
Okay. Does anybody know how many feet it would be if you're 394 inches? How many feet is that? Just to get like a better idea as to how tall this tree is. How many? A lot. It's pretty tall. What'd you get?
32 and an 8.
About 32 and an 8. He's getting specific there. So about 32 feet tall if you're 394 inches. Anybody have tall trees in the yard? Yeah. I think that some of the ones that we have at the edge of our lot they're really big evergreens. I'd say they're close to probably 40 feet tall. Any questions? So I'm not collecting that today. I'll be collecting tomorrow's because I want to get a better idea as to how you did after the second day. Your quizzes are done, and at the end of the school day, I will be putting them into PowerSchool, so you can check that definitely sometime after 3 o'clock. They will be in there. I'd say average was probably a 23 out of 27, missing like 4 points. That would probably be about the average for the test. A couple of people were asking earlier. I hope to get them back to you by Friday, but I still have 4 people that need to make them up. So until that happens, unfortunately, I can't get them back to you. But you do have another quiz on Friday, so I really want to get them back to you by then. But just, I'm hoping that by then people will finish making up those from being absent. So we are going to go back in your packet, and then we're going to do the activity that you picked up when you walked in. But in your packet, it's page 21. I just want to go through one more problem thoroughly with you so that you understand how we can create the sentences, make sure everybody's okay with using the calculator and getting the data from the calculator. Just to clarify things for everybody. So page 21 in your packet. So on page 21, we have data for the women's Olympic 100-meter run winning time. So these are the women that would have won gold in the Olympics for the 100-meter run. It gives us the initial year of 1928, but this is for like the data going from every 4 years, so 1928 to 1972. You don't enter in 1928, just enter the number 28. So if I were entering a 0, would represent 1900, so like a double 0. So you don't worry about entering, just enter the value. But if you're looking at these data values, does anybody know why it jumps from 36 up to 48 if we're in the 1900s? So from 1936 to 1948, the Olympics are supposed to be every 4 years. Why would it skip years? What happened in history from 36 to 1948 that you would skip the Olympics? Amanda? Yeah, the World War. So World War II happened pretty much in that time frame, and there were no Olympics. They skipped over 2 sessions of the Olympics there. Now the Olympics are like every 2 years because they do a winter and a summer separate. They used to do them all in the same year. So that's why the data was every 4 years here. That was just a little bit about Olympics. So see if you can come up with an equation. It says least squares, that's really best fit line, the line of best fit. It's called a whole bunch of different things. Come up with a correlation coefficient. Look at your graph. Decide is the graph linear or nonlinear. And then we'll talk about the rest of the questions. So we're going to hit the stat button next to the arrows. You're going to hit enter because we're going to edit the data. And then go over to your L1 did get deleted somehow.
I can wait my right on
Is that okay doing that? Okay.
Yeah, I'm sorry.
No, you're good. Just make sure you're okay. Okay, so somehow it got deleted. Do you have like dance programs stored in there? No. Don, did that work for you?
Yeah, let me see. No, I don't think so.
You said yes or no?
So, I might go home and still not until
And you have programs on there?
I think they're not on
Did you put anything else on there?
Well, yeah.
The only other thing I know is to like delete all of it and start over. Otherwise I don't know how to get the L2 to come back. Like I don't know how to insert it in besides doing that.
I'll figure it out.
And I don't have a calculator for you to use.
It's screwed up. It's not like it was supposed to be really quick.
Okay, why don't you do that? So I want you to be able to plug it in. Anybody having problems getting a graph, getting an equation? Calculator problems, and you're good. Alright, so I think most of you have everything plugged in. Morgan, what equation did you get? Oh, I'm sorry. That's right. We needed to enter that as checking it. Sorry for picking on. Damon, what do you have for A? Yeah. So 0.024, positive or negative? Negative, and then 12.71. So then the correlation coefficient is your R value. Amanda, what do you have for R? So if it's negative, what does that mean about your scatter plot? Right, so your points, the dots on on your graph, they should be going down. So if the correlation is negative, it should go down. It also tells you your slope is negative, therefore your line goes down as well. This is called a negative correlation. So if the correlation coefficient is negative, it's called a negative correlation. There's still a relationship between them, but it's a downward relationship. So slope is negative, the correlation coefficient is also negative. When you look at the points, do they make a line? Are they linear or nonlinear? Kelly, what do you think? Are they linear or nonlinear? So do they form to an exact, perfectly straight line?
No.
No. As a group, yes. They go up or go down as a group, but not as a single line. So they don't all match to a set of a nice, perfectly straight line. So that's nonlinear. Because if I connected them, I'd have to bounce back and forth between the lines to connect them. Letter D. Jake, what do you have for letter D for this slope?
Negative 0.02.
Yeah, so whether you have negative 0.024 or negative 0.02, either one of those would be the slope. Do you know what that means, Jake?
The times are decreasing by 0.02 every run.
Yeah, so every run, and that's a good way to say it, every run, every trial, the times are decreasing by negative 0.02 seconds. We'll say winning times. So make sure you have that word decreasing in there, that's why it's negative. Every run, every Olympics, something in that sense. For letter E, what's the y-intercept?
I have a question.
Yeah.
Why does it keep saying this square line?
It means the exact same thing as best fit. It means the exact same thing as linear regression. So they're interchangeable words. They all mean the same thing. Do you know what the y-intercept is, Adele?
Zero, 12.7.
And then what does that mean? So what does the year 0 mean?
It means so these are the numbers. 28 minus you get 16,
I think you're going too hard. Too hard. So if I have the year 0 with our data, what's the year 0 represent?
Is it 28?
Not 28.
But like that's the year 0.
That's the 28th year.
Oh.
Just 1900.
Oh, okay. I thought it was starting
So,
at 0. Like
so starting in 1900,
Okay.
then
Makes
28 would be then 1928, the 28th year past 1900. So in 1900, the winning time was 12.71 seconds. Which could be true. There were definitely Olympics in 1900. There were Olympics in the 1800s as well. So we could look that up and see if that's true because it seems like as years go on, people get faster. So that time could be at least in the vicinity of being correct. Lauren, letter F, how do we find an x-intercept?
You take the equation y equals 0.24x plus 0.71, and you make y 0.
Good.
And then you put the 12.71 onto the left side. So it'd be negative 12.71 equals negative 0.24.
So if you used negative 0.024, you're going to get a different answer than if you used negative 0.02. Lauren, which number did you use?
What's that?
So did you use that number in your
Yeah.
Okay, so what did you? That's fine. So who didn't use? Dave?
I got 635.5.
All right, so depending if you use 0.02 or negative 0.024, those would be the differences, which you see rounding, like using an extra thousandth there actually makes a big difference in years. So it just depends which year you use. So we'll put down both, or how you round it, I should say. So if you rounded and you used to 635.5, David, what year would that actually be? So if we started in 1900 and we're going ahead in time 635 years, what year is that?
2435.
You're so close. 2535.
Uh,
So if it's 635 years after 1900, it's actually the year 2535. If we use Lauren's number, Lauren, we would be the year 2429. Either way, they're so far into the future. So depending which number you used, those would be the years that would correlate. So in that year, the winning time is what? 0. Which, I mean, could happen. We don't know what's going to happen that long from now in 600 years. So maybe. So technically, the winning time is 0 seconds, either in 2535 or 2429, just depending the numbers you use there. The last two questions here talk about the year 1988. So if we want to find the time in 1988, what number would we plug in?
You would plug in
I think you're making it too hard. So you're just going to plug in 88. Yeah, it's the 88th year after 1900. And this is 10 point, is it 95? Yes? So 10.95 seconds if you just use 0.02. Damon, if you plug it into your problem with the negative 0.024, what time did you?
I got 14.
Okay. So it's a little different using the extra decimal place. The last question says, in 1988, Flojo won the gold with a time of 10 minutes, 10 seconds, 10.45 seconds. She was the American medalist for that year. Why doesn't our numbers match up? Why don't they match up? So why did she win it with 10.54, but our equation is saying it should have been 10.95 seconds?
Our equation, which is the average.
Right, so this equation we calculated was the best fit line, the average that goes through the points. It's not necessarily going to hit every single point. This piece of data wasn't even used in the equation or to create the equation, so they're not going to match up. Sure, it's a pretty good estimate. They're fairly close, but no, they're not going to be exact. So data points that you use to create a line are not always going to match up with the line unless all of them are actually on the line. Questions? Does anyone have questions with writing the sentences? Trying to explain what it means. Alright, so then if you want to put that away, maybe just keep it on the corner of your desk. The little page that you picked up that has a chart on it. So we're going to just do a little activity to see how well you are at guessing ages of different people. Some of them you may know, some of them you don't know. That's okay. It's okay not to know somebody. It actually makes your graph look a little crazier. But our goal is to see what the graph looks like and to decide if you're good at guessing ages or if not, and how that's related to a graph, a scatter plot, and how that's also correlated to the equation. So if you haven't done so already, see if you can take a random guess or maybe an educated guess. If you don't know the person, then it is going to be purely random. But see if you can guess the ages of those people. How old do you think they are? And then we'll talk about how old they actually are and see how good